Hello everybody, thanks for coming to the lecture. Sorry about the late start. I was getting a demo running on this machine and I just wanted to see if I could get it working. Okay, so let's move on with the next section of the course. So we're in week 8 and we're going to have a look at an overview of database web-driven development again. Last time we looked at relational databases. So today I want to show you a little bit about NoSQL and MongoDB databases. Okay, I just see a quick note in the chat there. Somebody saying about struggling to a database for step 1. In the examples, if you, Eugene, I can see you there and your message, and I suppose we'll just be, before we move on to MongoDB, we think a little bit about the relational database example. So I gave an example yesterday. I posted last night into Teams a fully working standalone program that connects to a relational database, and it connects to the web course database. Let me just go here. So if I go to web course here, you can see that we have this database, and if you click through to phpMyAdmin, it allows you to be able to log in. So I can log in here, and I'm using a database called CS230. You will be using a database CS30_U and whatever your username is or your code is. So that will allow you to get in here. So that will be your database, and you can use that to create your tables with phpMyAdmin. Then you can use the demo programs that I gave you to make sure that they work. And that will do and show you the correct steps for all of the connections to the database. And will also show you how to use callback functions and so forth to make and add something to a database and return something for the database. So you can use that as a basis for connecting and as a basis for your assignment. Okay, so for your first assignment. So, or sorry, this current assignment. So it should be fine. It should work for there. The issue, of course, yeah, I mean, you have to really know what you're doing and have some experience in order to be able to set this up with XAMPP and that's grand. You know, I mean, you can learn how to do this. So, I mean, I have it working here, and I also have my servers running here. So I have my MySQL database here, and I can start it. But you have to, when you have started it here with XAMPP, if you're using this, so my Apache web server, I just want to start my MySQL server. I'll start this one. If you want to do things this way, of course, it's good to get going. So now we're here, so we can go to localhost and see it's working. So so I know my localhost is working. And if you go to your localhost, you go to phpMyAdmin at the top right corner, you know, it should be fine. Now, if you and that will log in for you, but you have to ensure that your database is running here when you start XAMPP. Okay. So that's fine, okay, and it's possible to do that, and it can be a bit of a mess, and you can try to connect there, and it is a bit of an issue. But the problem with this is that if I have it running locally on my own computer and I have everything working fine, then you submit your assignment. We have no way of checking that will work because it's the database is on your computer. So that's why we're recommending, well, I say recommend, in order to be able to make it work, we want you to use web course. Okay, we want you to go back and use this online web course. It's every student in the department has access to this. You can log in, and you know, if you go to the portal, you'll be able to get your details. And so I'll log in here, and you can see if I click here, I get all my database details, and that will give you the login details that you can include in your program. And I gave the code for that program yesterday. I posted it to Teams. So you know, there's a fully working program there that everybody should be able to use as a starting point for this particular assignment. If you have issues with it, that's why we have labs, you know, and I ask people to go to the labs for support, and the demonstrator will make sure that you can log in and use this. So it's an important activity. There's no point having everything set up on your machine and working on a local database for an assignment. We need to have it somewhere that we can take your program, run, and be able to log in and access. And that's why we have this service available for you on web course. Of course, knowing how it all works and getting it working is fine. And you know, you can always come and talk to me about this. I mean, I'm quite happy, you know, making an arrangement, and I can have a look at your exam setup and see if we can get it work. Students contact me all the time about various issues they have and solve some of the problems. Some I can't solve, but you know, a lot of it has got to do with the setups in your machine. And one of the reasons I was a little bit late today was because I was trying to get MongoDB working on my machine here. And I can tell you a little bit about that. in a while, but let's get back to the actual lecture. So I hope that answers some of the questions for you there. You were trying to connect to a database over 2 hours during the lab. I mean, the system should be available. Usually, if you can't connect, there's a password problem. But you can come and see me, and I'll have a look. If it's a technical problem, you can mail me. Maybe there's a problem with your setup, and we can get the tech to have a look at it for you. But the best thing to do would be to take my working program that I know works, and then use your database and set up from there. Okay, so maybe talk to me on Teams, and I'll help you out for sure. Right, let's get on with this because we started a little bit late. And really what I want to do today is I want to give you this overview of NoSQL, a document design for web development. And this is an alternative setup for your database. So really we're in week 8 and this is something we're going to look at today. So we're going to focus on database design, again, with building around the NoSQL database as opposed to a relational database. So we learned a little bit about NoSQL databases here, getting started with MongoDB document database, and then how we model documents for use in NoSQL. And then the lectures that I will release later this evening will give you a lot more details on how to make that work. Okay, so the NoSQL database world, and it doesn't mean NoSQL, it means not only SQL, okay? And how it works. So we've been looking at, and you have since first year been looking at relational database modeling for conceptual, logical, and physical representation of the data that we use in our applications. It's very traditional, it's workable, solid solution, but it's not always appropriate. It requires this singular perspective on the structure of the underlying data to be a relational model, and not all data fit nicely with relational models. So modern data especially, they're not structured as tables. So it can be inappropriate then to try to take the model of the world and force it into a table so that you can work with it. And you can lose really key information embedded in the structure itself. For example, if you have data that are organized as a graph, then it becomes problematic if you try to organize that as a table. And I can give you some examples a little bit later if you ask or you're interested. Okay, so querying a graph then is really well understood. You know this from your data structures and algorithms, but if you have to take your graph and then map it into a table, then querying it becomes a bit more problematic. So we don't really want that kind of thing if we can help it at all. You would end up using a query language based around graph theory rather than organizing it as a table and using a structured query language SQL in order to make it work. So this is why we tend to have collection-based databases. So data organized as documents then may not actually be suited for tabular organization. So it could be necessary to have the collections of documents that are related don't have the same structure, same kind of loose organizational structure, or some kind of schema in place. So NoSQL then stands for not only SQL. Sometimes it's NoSQL and sometimes not SQL. It's an approach to database design that provides flexible schemas for the storage and retrieval of data beyond the traditional table structure that is found in a relational database. It's non-relational database management system that does not require a fixed schema. So it avoids all sorts of joins, scales easily, and it's used to create distributed data stores that have extremely large database requirements. So lots of the big databases in the back end behind all their popular online tools will all use NoSQL rather than a relational database. So it's used for big data. And it's used for real-time web applications used by companies like Twitter and Facebook and Google, all collect terabytes of user data every single day. So terabytes per day on an individual user. And think about the millions of users that are there. We're not going to be able to work with these kinds of data with relational databases. The NoSQL database really scale up better than the traditional relational ones. They're designed to work well with big web applications. And scaling out refers to distributing the database on multiple hosts when the load increases. It's a much, much better approach than scaling up systems by upgrading our existing hardware, which is very, very expensive. So I'm sure you've heard about NoSQL already, of course, in your modules and databases. So we're going to review the features of NoSQL here and jump right into using one, MongoDB, which I use for my web applications. And I can show you quickly my MongoDB. I recommend I use the online cloud version of MongoDB in order to be able to, for my data. So this is a hosted service that's free. And you can see that I have this Ajax Api Demo, and you would have seen the one that I had when I logged into web course you will see I have an Ajax API demo here for my demo applications, where I have a table that stores the data that I use for my demo applications. So if you look, you can see I have a first name, a last name, and an email, and that's all organized as a table. But if we look at my relational database, you'll see that I have a first name, an email, and a last name organized as a collection, as a JSON object, essentially, that sits within my databases test, and my collection in here is Ajax API Demo again. So we think about having a database, which is the same within Mongo, like which is an example of a NoSQL database. So we have a database, and we have a database when we use a relational database management system. We have tables in relational database management system, but we have collections in of documents in this MongoDB environment. So that's fairly straightforward, and I can connect to this database and access and manipulate it just the exact same way as I did for my relational database. So as I said earlier in response to a good question there by Eugene, that I posted an example during the intersemester break of a Node.js application that had an in-memory database that we could talk to over HTTP, and we had essentially this API connection. And then I replaced that with the one that I uploaded yesterday to Teams with accessing a relational database. So the next one that I will upload will be how to do the exact same thing again, maintaining and preserving the full front end, but just changing the back end so it accesses this MongoDB or NoSQL database with collection. And the beauty of this one is that these are JSON. So I have JSON in my data, JSON in my app on the back end, JSON passed over jQuery to my front end, and been able to manipulate the JSON JavaScript front end. So full stack JavaScript, JSON as the data that switches and moves back and forth between all the various tiers. So this is why it's powerful, and this is why we use it, and it's really, really nice. Okay, so we will be using and seeing MongoDB for your web application. So it gives you another alternative. And of course, you can use PHP connect MongoDB as well. And so all of these tiers in the various architectures, they're in many ways independent of each other. You can swap out one for another. So you might decide I'm going to mean, M-E-A-N. M is like MySQL up until now, but we can switch that out for MongoDB. E is Express, which we haven't done yet. We'll do in a week or so when we're building APIs. A for Angular, N for Node.js. But in fact, we could swap out the N and just pop in the Perl, or sorry, the PHP from LAMP if we wanted as well. And we could pop out the A for Angular and use React, have a MERN tab up. So it all works just nicely. Okay, and pop out the various tiers. I'm about giving you alternatives. When you find one that works for you, and that would be to do this. Okay, so the summary, the main features of this NoSQL database are schema-free. You have that structure of it being a table and so forth. They're eventually consistent. That's the base property. The replication of the data stores to avoid a single point of failure, so you can replicate over different clusters, and you can see that and read a little bit yourself. And you can handle data variety and huge amounts of data. So we talk about this base property up here, and base refers to basically available soft data eventual consistency model. Okay, where basically available refers to the availability of the data, meaning that there would be a response to any request, including failure. A soft state means that the state of the system can change over time. Eventual consistency means that the system will eventually be consistent once it stops receiving input. That's a feature, and you may have come across. I mean, this isn't a database course. You do all this stuff in databases anyway. I'm just trying to make some connection with your earlier database. So what are the kinds of NoSQL databases? Well, they fall into four main categories. Okay, so the first one is where you have key value pairs. So you have for storing data or data stores like Redis and DynaDB. Wide column oriented graph stores like Cassandra and HBase. You have graph databases, which is Neo4j, which is like really popular and it's brilliant, JNUS Graph and HyperDB Graph. And you have document-oriented databases like MongoDB and Apache CouchDB. So all of these categories has its unique attributes and limitations. There's no specific database better to solve all the problems. You should select the database based on your product needs. But the IBM and the MongoDB provide really excellent summaries of the differences between the databases. You can click through here, and it tells you a little bit about them, and it's worthwhile maybe at your leisure doing this sometime. more about it. But as I said, I've highlighted MongoDB because we use this one. It'll be our example. It'll be our go-to NoSQL data. So we could check and see, but key value databases, they're simple kind of database where every item contains keys and values. And you know about these key value stores. You've seen them as hashes in your JavaScript. The value can be retrieved by referencing its value or its key. So learning how to query for a specific key value pair is really, really simple. So key value databases are great for use cases where you only need to store large amounts of data, but you don't need to perform complex queries on it. And that may be storing user preferences, caching, all that kind of. We have white column stores. They store data in tables, rows, and dynamic columns. And white column stores provide a lot of flexibility over relational databases because each row is not required to have the same columns. That's really nice to be able to do this. Many consider white column stores to be two-dimensional key value database. And they're great when you need to store large amounts of data that you can predict what your patterns will be, your query patterns will be. And white column stores are commonly used for storing things like Internet of Things data and user profile data. Graph databases store data as nodes and edges, and you know about graphs from your data structures and algorithm. And nodes typically store the information about people, places, things. Edges store information about the relationships between the nodes. And graph databases really excel in use cases where you need to traverse relationships and look for patterns such as networks, social networks, fraud detection, recommendation engines, all that kind of stuff. I had a fourth-year student last year who worked on organizing biographical data for Irish migrants to Europe in the 18th centuries. And we were trying to find out the relationships between people who migrated that were part of the armies at the time in early modern Europe, trying to look at, the relationships to the crown and the various kingdoms. And we were interested in people who were involved in the church, and priests and so forth. And tried to find all of these kind of relationships and model those data. Not easily modelable using HTML, so we switched and used XML, and then we used JSON, and then we were able to try to put JSON into various databases. And ultimately, because these were graph data and we wanted to look at social networking in the 1800s, we were able to do all this work using graphs in Neo4j. Node.js programs accessing Neo4j rather than MongoDB or a relational database. But it was nice because we didn't have to work too hard to change the structure of those data. If you're interested, let me know and I can show you an article on the data published this week, in fact. We have document databases, which is the MongoDB type stuff. And really, we talk about documents. Documents are basically similar to JSON. Very often they're called BSON, okay? But as well. And every document contains pairs of fields and values. And the values are a variety of types, including strings, numbers, booleans, arrays, objects of any of that structure, and they typically align with the objects that people have when they're working in code. So because of variety in field value types and powerful query languages, document databases are great for a wide variety of use cases and can be used as general purpose databases, which is why we use them in this course. And they can horizontally scale out to accommodate large data volumes really powerfully. Okay, so this is an excellent overview, as I said here, showing this on Free Code Camp. And it was worthwhile having a look. If you click through on this link, it's really nice if you want to know about knowing these databases. I'm sure you've done some of this already in your course, but it's a good review. And for those of you that haven't, the same degree of familiarity might be worthwhile reading an article like this. But for this course, anyway, we're going to be using a document NoSQL database called MongoDB. And it's consistently ranked as the world's most popular NoSQL database, according to the database ranking site, DB Engine. So if you go to DB Engine's ranking, you'll see MySQL is second on that list of all database engines. So, you're learning about MySQL. It might be an older technology. It's been around for a long time, but actually it's very popular and it's still used. And lots of problems and things that we work with, they will connect through to a MySQL database. Okay, but MongoDB is really good. So let's get started with some MongoDB. So it's a general purpose, document-based, distributed database built for modern application developers in the cloud era. You go to mongodb.com, you can log in and you can try it for free, and you can sign in and you can have an online database. You can also download MongoDB and install it and have it running just the same way as you did with XAMPP. Now, I had a problem with mine because I can tell you technically what the issue was for mine. So I installed MongoDB on this machine. So Okay, so this is a Apple MacBook Pro, and it's one of the new M1 MacBook Pros. So when I created this MacBook Pro, when I bought this MacBook Pro, I actually did a clone of my other MacBook Pro. But because it's an M1 MacBook Pro rather than an Intel MacBook Pro, then I ended up migrating a lot of my installed software, and most of it will work in some kind of emulation mode, but some won't work. And it turns out that MongoDB Community Edition that I installed using Homebrew just won't work. And it didn't work out of the box, so I had to work through and try to do some installations. The further problem, now Brew is pretty good, Homebrew is pretty good. It does allow us to be able to install on the server here, but it doesn't like the fact that I haven't upgraded to the latest version of the operating system. And I never upgrade my operating system mid-semester. So it wants the most modern command line tools in order to be able to set it up and work and configure for the M1 chip. So I'm not allowing it to do this. So I've been trying to do some workarounds and hacks, and it's probably a bad idea to dig into the guts of the underlying Unix here. So I've stopped doing it, and I may just do an update and hopefully it'll go okay. But I can still use the tools, the Mongo shell tools, and connect to my service online. So I'm connecting here. So I'm using the Mongo shell, which I've installed with Homebrew, and you can download and install this. And I'm connecting to this cluster, which is my online cluster, and I'm connecting to the test database on that cluster. I'm logging in as my user, which is my admin user, and so I'm popping in my password there, and so now I'm connected. So I don't worry about the errors for here at the moment, but I'm here, and I can just so now I've connected into my database, okay, as a command line. This is the exact same as my connection to the database here that I've connected in here. So I have this view which I can log into, which is Atlas Cloud from MongoDB, and it's a bit like your phpMyAdmin. I can do all sorts of work here, or I can do stuff from the command line if I wish. So I can show my databases. So I have 3 databases here. You can see test and so forth. And I can say use test to use the database test. I'm already in test because that's not surprising, because I logged in. And when I logged in, I told it to use the database test here. So surprising. So I'm here, and I can show my collections. And I can see I've got a few collections here. Okay, so that's nice. You know, I can access the collections if I wish. And these would be from different examples that I would have used here along the way. And continue to see the Ajax Api Demo is the exact same collection list as I have here. Test.ajax API. So this is the one we can use. So it's fairly straightforward to be able to get in and start using these. Okay, so to get started, you have to install a client on your computer, and I did that using, I'm a Mac user, so I have to use Homebrew. And if you go to your here to your resources section in the manual, it'll tell you how to install MongoDB and how to install the various shells and so on. And you can have a look at that. Okay, it's easy to do for your operating system. Okay. So as I said, I use Homebrew in order to use, and I was using Catalina, so I've changed my operating system since then, so it's a little bit different. But you can download the full community, and you can have a client, which is Mongo, and a server, which is MongoD, which is the daemon. Instead of Mongo, you also now have Mongo SH, which is the Mongo shell, which is the one that I'm using currently here. Okay, but the Mongo will work too. So there's lots of ways of doing this. So the server essentially implements and provides a full database manager. It runs on port 27017, and it's the primary daemon process for your MongoDB system, and handles all the storage requests, all that stuff. You don't have to do that, but if you want to really get a feel for how it all works, you know, you can put it onto your local system. I would recommend using the online system. Okay, the standard client, which is Mongo or Mongo SH, that's a command line app, and it's the Mongo shell, and it connects as an authenticated user and allows you to have the interactive interface here, which is this one here that I'm showing you here, that allows you to interact and engage with your, or you can just go to your online and start and interact with your database here if you wish. Of course, what we're really interested in doing is being able to connect to this using Node.js or PHP. So these Shell, Mongo Shell, and Daemon, they're available as part of the MongoDB server installation. You can just install this, and there are alternative apps that you can use. I also use Studio 3T, or and there are lots of different ways that or Compass is another one that you can look at. If you want, you can just search for Compass. And so you can look at Mongo Compass, and you can go to the official site, and then you can choose the right. Well, you can use Studio 3T if you want, or you can just use Compass. There it is. And this is an app that you can use as a downloaded GUI, and it works. It'll download it for whatever operating system it's written. It'll work everywhere. There's lots of ways of accessing it, and no issue with that. As I said, the alternative to downloading MongoDB, and this would be preferable for you, is to actually use the MongoDB Atlas. And that's the online, and you can connect to it by mongodb.com/cloud/atlas. You don't have to host the server yourself. You can create a free installation. And the good thing about that is that if you use it for assignments, then we have access to that as well. It's easy to correct your assignments. You'll have it for your exam, all that stuff. So there are some great sites that walkthroughs on setting up a MongoDB Atlas account. I created a second account that worked just nicely, and I think I show you some of the demos that I have. So there's lots of the things. I show you how to use Mongo, MongoDB Atlas in the next lessons. And they're getting started with MongoDB. So those videos will be available for you. They might be out of date, but the basic idea is still the same because it changes weekly. Okay, so if we want to compare MongoDB, this collection-based database from a NoSQL database with a relational database management system, then we have to know a few things different. So here we have our relational database management system, MySQL, our MongoDB, which is our NoSQL system. When we talk about rows, in relational database management systems, we talk about documents. When we talk about columns, we talk about fields in NoSQL. When we talk about tables, we talk about collections. And here's an example, of MongoDB. And essentially, you can see that these are just like JSON right here. They're just JSON. So they're specified using JSON. That's the whole point of this and making it easy. So you need to know the difference between documents, fields, and collections as opposed to rows, columns, and tables. And the document represents information about, for example, these examples here, the document represents information about a member whose F name is Joe, has fields organized as name value pairs. And documents can be collectively stored in some logical purposes collection, or a MongoDB database consists of one or more collections. Just the same way as a database can have more than one table. And if you have a relational database containing numbers of tables, because you will have maybe one table which associates a person with an address, and then you may have another one which is the table which is the relationship. So there's no MongoDB equivalent to this traditional primary key. In a relational database management system, the physical model, we define one or more columns as the primary key to give this row some kind of unique feature. No requirement for MongoDB. Every time you insert a data, you automatically get an ID created when it's inserted into the collection. So you can see some of the ones that I have here. Here would have been the three pieces of data, F name, L name, and email. And you'll see that this object ID was created automatically. So this is like the equivalent of a primary key. I'm still not 100% right, so I'm just going to pause for a second while I just get some water. Okay, just give me one moment, please. Okay, thank you very much for waiting. So this ID field is an object ID instance and guarantees uniqueness in this document, as shown, like you can see from the fragment that I showed you, and you can see here, find various items. So we want to be able to do something here, so we can do some corrections. Here's some commands. So we can these are commands that we can have for manipulating databases in a NoSQL environment. So let's have a look and see, can we do this? So I'm here with test. So I have my collections here, Ajax Api, customers, documents, quotations. So I can use test. So I'll just issue the command again. So we know we're here, we're already on the DB test. Okay, so we want to insert this record into the foo database. Now you can see we don't actually have a foo database here. Okay, we just don't have a foo anywhere. So but when we create a collection and we insert it, it will create that for us. So we can just copy this. Copy it here. So I'll say db.foo insert this record here. And so I've created this. So I've inserted this record into a database, into a collection called foo in my database. And you can see now it's after created this object ID as well. So we can find this by issuing this command find on my database collection foo. You can see I've done this here. And I have found my record, and you can see the object was created. If I now say show collection, you'll see that this one is here. It's been created. So it's useful, you know, and we can, in fact, we can see what's in some of the other ones as well. You'll notice the command we issued was db.foo.find. We'll now say db.ajax API Demo.find. You can see all the records that I've inserted into this. And you can do all sorts of, you can look up the find command and see there's all sorts of filters you can do on this find. Okay, I can delete as many as I like. So I could delete probably everything here. Let's have a look at this. You want to be careful with this command, folks. Okay, let's do it. Okay, so I've deleted one. So now if I try to find, there's nothing in my foo, and is my collection there? Yeah, my collection is still here, and I can just do this, I think, db.foo.drop. I've dropped it, it's true, and I can have a look at the collections again, on my collections. You can see it, once you have user privileges on these, you can do all sorts of really powerful things. So you need to be very careful that you don't mess up your databases by issuing something like delete and delete many and drop and lose all your data. You have to be very careful about it. Okay, so manipulating our database is very similar to working with your normal SQL commands that you would have had and seen last year. So, so you can find out lots more about object IDs if you click on the reference manual for MongoDB. And it also allows you to be able to create indexes on any kind of field to boost the query performance. And this auto ID, object ID that's generated here, that's automatically indexed. If you create too many of the indexes, you would have a negative effect on the importance. So you can find out lots about indexes here. I want to tell you about this because you might want to do this to make comparisons with your relational database. You would have done that before. You would have created an index on a field in a table. And this, of course, all has to do about primary keys and all that. So you can actually model data with NoSQL. We know they're collections, but it's slightly different process undertaken for a relational database model. Okay, like say MySQL. It's possible to have relationships that connect documents using a reference, and that's called a normalized model. But it's also possible to use an approach called an embedded model, embedded approach. And that's a denormalized. So when we're working with relational databases that are manipulated using SQL, we went through a design process that would be conceptual and logical and physical into the relationship diagrams. We eventually determined the design table schema that were, before we inserted any data at all, With Mongo's DB collection, and by default, you don't require documents to have the same schema. And the modeling guide from MongoDB tells us that the document in a single collection do not need to have the same set of fields and data, as the type for a field can differ across documents and collections. And this flexibility facilitates the mapping of documents to an entity or an object. And each document can match the data fields of the represented entity, even if the document has substantial variation from other documents. So in practice, the documents in a collection usually share a similar structure. You can force some validation rules using an update and insert operations using a schema validation, and you can click through here to find out about that. And there are two approaches to the normal design: normalized and denormalized. See a little bit about that later again. So here's a normalized data model using references. So we could have a customer ID, fname, Joe, an address ID, and a customer ID and address ID, which, there are lots of ways to do this. So it's possible to create a series of related collections in order to establish a normalized data model. And references store the relationship between the data by including links or references from one document to another. So you can see here, we have a customer ID and an address ID. And here's an address ID and the details for this address ID here. And here's the customer details for this customer ID. And here we have a record which has both of those. So that's kind of like a normalized data model. It's a bit like the kind of thing you would do with relational databases. And applications then can resolve these references to access other sorts of related data. They're normalized data models. So a normalized data model could be established by defining a key fields, customer ID and address ID, which form a reference between customer, a collection, and addresses. You wanted, you could do this. Okay, some authors advocate you don't do this, as it defeats the purpose of having a NoSQL database. It relies on your database driver functionality to handle embedded links between connections. You may be required to manually write code to do this. It's an unnecessary overhead that can be avoided. You can find out more information on referencing in this link here. In general, the MongoDB manual recommends using normalized data models. When embedding would result in duplication of data, but would not provide sufficient read performance advantages to outweigh the implications of the duplication, to represent more complex man-to-many relationship, or to model hierarchical data sets, large hierarchical data. MongoDB provides referencing to join data across collections. For the embedded model, which is the denormalized data model, and some people would say that that's a better approach to data modeling, would be to collapse the normalized relationship and fold the relevant and related information into the embedded documents, as described here in this link. So embedding documents capture the relationships between the data by storing the related data in a single document structure. And MongoDB documents then make it possible to embed document structures in a field or an array within a document. And these denormalized data models allow the applications to retrieve and manipulate related data in just a single application, a database query. So this is interesting. So here you might have the name and the shipping address and billing address. This is kind of stuff that you're looking at in yours. It's really useful to have it this particular way. So the embedded data model allows applications to store a related piece of information in the same database record. So the application, your Node.js program that's making a call, for example, it needs to make fewer query or updates to complete operations. So according to the MongoDB manual, you use embedded data models when you can have contains relationship between entities. So you can have a look at the one-to-one relationships in embedded documents if you want. You have one-to-many relationships between entities, and these relationships, the many or child documents, always appear with or are viewed in the context of the one parent document. So you can have a look at the model one-to-many relationships. Search on that. So in general, embedding provides better performance for read operations, as well as the ability to request and retrieve related data in a single database operation. Embedded data models make it possible to update related data in a single write operation. So I guess what I'm saying is that there's more than one way to do this. Some ways are better than others. You have the flexibility to do what you like, or don't have the rules. You have to decide on something and go with it yourself. This is the approach that I would recommend. Well, not just me. MongoDB themselves recommend this. So the key decision is designing the data models when you're designing data models for MongoDB applications revolves around the structure of the documents and how the application represents the relationship between the data. So, and because MongoDB allows related data to be embedded in a document and use references to other documents, so which way do you go? So one approach when designing that will ultimately end up in collections is to begin with the design process and identifying the views that will be required. So you have to work backwards to decide on what documents will need to be created then. That was the approach that was used earlier, for example, when our application might want to show a display with a customer name, shipping, and a billing address, as we have in assignments. Either approach works for storage, but you have to decide what works best for your design and application. Modeling application data from MongoDB should consider the various operational factors that impact on the performance as well. Now, your databases are going to be small, so there's too much of a performance issue. Think about it and understand how many queries or writes am I doing in order to perform an operation. Different data models allow more efficient queries, increase the throughput of insert and update operations. Like this. So if you want to model, then you've seen that like conceptual, logical, and physical model for relational database systems. So we have to be familiar with entities, which are documents, relationships, and cardinality. Relationships in the NoSQL context show how MongoDB documents are related to each other. So here's a brief summary of the different kinds that you might have. So a one-to-one relationship exists when one object or an entity is related to one and one only object of another entity. So for example, a user could have one and only birth date. So if you have a document that stores the user information and another document that stores birth dates, there'll be a one-to-one relationship between them, for example. A one-to-n or one-to-many relationship exists when one object or an entity can be related to many objects of another entity. So for example, it could be a one-to-many relationship between a user and their contact phone numbers. In other words, they can have more than one phone number. We have a many-to-many relationship or end-to-end relationship when one entity is related to many instances or objects of another entity and vice versa. So for example, in the case of users and items purchased by that user, one user can purchase more than one item, as well as one item can be purchased by more than one. So you have to remember these key things when you're designing and developing, working with your databases, eDay, MongoDB, or otherwise. So we've already seen this before, okay? And essentially, this is a logical model when we looked at relational databases. But we can still use this, okay? So this is the model, but we won't be working with primary keys and so forth. So you have to think in terms of your data model as opposed to the physical model. That's the implementation model that sits in MongoDB. You might say, how do we do this using documents specified with JSON rather than tables relationship? Something you have to figure out and start thinking about and working with. Okay, so data modeling is really, really interesting. And yeah, it's fun. Okay, it's absolutely fun. So you have choices. You have choices. You have another choice. So you would have had, up until now, for the back-end work, you will be working with your Node.js or PHP as your back-end processor. And that back-end processor may generate the code, of course, so dynamically generate the code for the front end. Well, or it could be called by some standalone front end. Then those backends can talk to a database. So if you could only talk to a MySQL database, you would have had two options. Node.js talking to MySQL, PHP talking to MySQL. Now we're introducing another option. We're introducing this option of Node.js database. So now you have 4 different approaches that you can use for building your backend services. You can have Node.js talking to MongoDB. You can have Node.js talking to MySQL. You can have PHP talking to MySQL, PHP talking to MongoDB. In fact, you could have Node.js talking to both a relational and a MongoDB database. Sometimes I ask an exam question. How do you copy all the data from a relational database into a MongoDB database? So, you have 4 possibilities here. If I was to give you another day, if I was to say Neo4j was an option for you to have as a database, you'd have a huge number of options. You'd have 3 for each service, 6 different ways. So, in general, I will ask you to start doing and working with assignments unless you need you to do something specific now. Let's say, well, when it comes to the examination, you will be building a piece of software. And I won't specify what you do use. You can use Node.js, you can use PHP, you can talk to MongoDB, you can talk to MySQL. I don't mind what the parameters and choices you want to work with, as long as the exercise that you'll be given will actually, map onto any. But then you have to remember that you may have to design your data and how you organize and design your data model. You have lots of choices for that as well. You'll have to look and trying to get the most efficient way to do this for you. But sometimes, you might want to use the way that's easiest to code, might not be efficient. We don't have any penalties at this stage for inefficiencies, because the quantity of the data that you'll be working with are so small. Terabytes of data per user that the likes of Google would use. But it's worthwhile bearing in mind good models often lead to simpler designs, and simpler designs leads to nice, clean implementation. So what's coming next? So we're going to be looking at database modeling using the documents in more detail. How do we realize one-to-one, one-to-many, many-to-many? We see some basic MongoDB commands, how to create and search and manipulate databases using the Mongo shell. I showed you some basics there. Best to use Mongo. You could use the Mongo shell locally, as I have done here, connecting to the Atlas cloud version rather than the local installation. I'll get the local installation working because I like to have them. Yeah. Okay. And so we'll cover all this in the next lecture. Thank you very much for watching. The exam information and all the assessment guides are on the Moodle page. Generally, you have 2 exams. You will have a quiz and you will have a 24-hour coding exam, and it's all in detail in the administration section for Moodle, and I will be giving a lecture on examination for the next few weeks. So maybe we can save the questions for then, or you can mail them to me in advance and have a look at those documents first. Okay, thanks for coming along today. I do appreciate the feedback, and if you have issues with your local installations, maybe talk to me in Teams and we'll try to get you sorted out. Okay, thank you very much. Have a good day, and thanks again.